Hi, and welcome to the section Reactive Programming using Python. The first topic in this section is Introduction to Reactive Programming. So, we will be covering the following topics in this lecture. What is reactive programming? Then we will discuss about the Reactive Manifesto. Then we'll move over to advantages of reactive programming. So, let's go ahead. So, what exactly is reactive programming? Reactive programming is based on asynchronous model of execution. Recall that in one of the previous sections, we mentioned that in asynchronous models, the processes do not wait for each other. So as soon as they find that the CPU is free, they execute. They do not wait for the previous process to finish, etc. So reactive programming is basically based on this model of execution. So there are no blocking calls and other things that happen in asynchronous model. Everything is considered as streams in reactive programming. Database calls, user clicks, failures, API calls, etc. So basically, while we are designing systems that are reactive in nature, so everything or the basic unit of input or data transfer is basically a data stream. So anything that happens, say a user clicks, or you call an API, or you fetch something from the database, or even a failure, everything is treated as streams. Data from different streams can be combined, manipulated, and transformed. So, what this means is that if you have, say, different streams of data, you can somehow manipulate them to create new or basically merged forms of streams, or you can transform existing streams, etc. We'll go over this in the subsequent videos. So the main crux of basically reactive programming is that you basically apply the asynchronous data processing over the various streams of data that you have in your program. Okay, to basically more understand the principles behind a reactive system, we need to discuss the reactive manifesto. You can think of this reactive manifesto as the requirements that are to be fulfilled if you are claiming that your system is reactive in nature. So you can think of reactive manifesto as the requirements that are to be fulfilled if you are claiming that your system is basically reactive in nature. So what this means is that these requirements should be fulfilled by any means. So let's go over them. The first is that your system should be responsive. This means that in case of any change in the system, the reactive system should focus on providing fast and consistent response. So the responsiveness applies to, like, you can say, an immediate change in the user input, or even in the case of failures as well. In the event a failure occurs, your system should be quick to respond. It should not be that it is stuck or hanging or there is some delay. Your system should be elastic in nature. What this means is that under varying amounts of loads, your system should function without any failure. Resilient. The system must stay responsive even in the event of failures. So there are various things that come into play to achieve this. First thing that comes to mind is basically containing that component which causes the failure and isolate it basically. Then you basically delegate the task that was to be achieved by that failed component to some other component. The point is that there is no single point of failure in this case. So the system should not fail. Like if one component fails, it does not mean that the whole system should just fall apart like a deck of cards. Also, one more thing to note here is that the high availability of systems or the responsiveness of the system is also achieved by replicating the components as well. So my point here is that these requirements are intertwined with each other, like as you have seen here, that responsiveness, elastic, resilient. Like in this case, like So these three requirements are basically intertwined with each other. It's not that one is not dependent on the other. And finally, we have message driven. So what this means is that there is asynchronous message passing between different components. So this basically ensures that there is loose coupling between the components. Hence, there is no single point of failure, and thus the systems are resilient, responsive, and eventually elastic. So basically, these are the main requirements that are to be followed by a reactive system. You can read more about it here in the Reactive Manifesto for reference. So I hope you understand the idea behind reactive systems, and this will also help you understand like why are we studying this reactive programming in high performance computing. So reactive programs or systems, so reactive systems are basically designed to be, fault tolerant and just quickly react to any changes in the environment, etc. Now let's move over to advantages of reactive programming. Reactive programming aims to allow the programmer to focus on the data streams and not the asynchronous part of programming. So what this means is that the idea behind reactive programming is that you don't need to basically like deal with how the systems are communicating in the asynchronous way, but you just focus on the data stream. So most of the modules that are there existing on the internet to help you design reactive systems, so their basically point is that the programmer should focus on how the data is to be manipulated and not how the various components will basically communicate with each other in an asynchronous way. So you can also, the reactive modules are basically designed to allow the programmer to make complex use of threads without going into the details of how it is happening. Also, you have an improved use of resources in an asynchronous context. And as we have seen, reactive systems are loosely coupled and scalable, allowing them to be more fault tolerant in nature. So a quick recap of what we have learned. Reactive programming uses asynchronous model to process streams of data. Everything in reactive programming is treated as streams of data. So the idea of reactive programming is to basically abstract out the details of asynchronous programming to allow the programmer to focus more on the logic part for manipulating data streams. Also, reactive systems are designed to be responsive, elastic, resilient, and message driven. So for reference, you can refer these links. So I hope this gave you an idea of what exactly is reactive programming, what are reactive systems, and how basically they fit in this high performance computing environment. So that's it for this lecture.